In this video, we're looking at a discrete probability distribution, and we want to answer some questions about that. So first off, we want to use that to find some probabilities. We'd also like to calculate the mean and standard deviation as a measure of center and a measure of the amount of variation, and utilize those tools to talk about usual values. The discrete probability distribution that we're looking at is individuals who were surveyed about the number of medications that they take daily. So first thing we need is the actual distribution. And we have here as our variable the number of meds, M, and then we have the probabilities, so P of M. And we remember the characteristics here. So this is our total sample set, which goes from 0 to 6. Those are all the possible values. And we have a probability for each one of them. Those probabilities are all between 0 and 1, and their total is 1. So it meets all the characteristics of a discrete probability distribution. So the first thing we're going to do with this is look at using it to find a probability. And so we're asked, find the probability of taking 3 or less medications daily. So I'm looking at my table, and here's 3, and then or less would include all of those that are less than 3. And so in order to find them, I'm just going to add up the probabilities for 0, for 1, for 2, and for 3. So I want to include all of these. So 0.18 plus 0.41 plus 0.13 plus 0.08. I'm going to my calculator to do that, and when I plug all of those into my calculator, I get an answer of 0.8. And that tells me 0.8 is the probability of taking 3 or less. So when I'm looking at a random variable and its probability distribution, these probabilities are given to me, and they can be added to answer a question. So the probability distribution describes a population, because these are all the possible outcomes. It's not a survey of outcomes. When we're dealing with a discrete probability, all of the outcomes are listed. And so values like the mean and the variance and the standard deviation, we would call them parameters. So we talked about previously the difference between a parameter for a population, a statistic for a sample, and we'll use the word parameters for the different measurements that we calculate. The wording for these problems talk about the expected value. And we didn't talk about that before. It wasn't one of our parameters, but it actually is. It's just a different language. So when we're talking about the expected value, we usually use an uppercase E. And so that would be the expected value of what? And in this case, our variable is M. So the expected value for M. And this is the key thing. It equals the mean. So the expected value is just another way of expressing what is the mean, which we understand what is the average. And because this is a parameter, we would use the Greek letter mu for that. It has a formula, and I encourage you to write this in your notes so that you have it on hand. And mu, the mean or expected value, is equal to the sum, remember that uppercase sigma, add up, the x times the probability of x. Specific to our example, we would say that the mu is equal to the sum of m, because that's our variable, times the probability of m. And that would be giving us the expected value for m. So if we're just asked what is the expected value, we're really finding the mean. So let's look at a question. If we were to randomly select one participant from this survey, how many medications would we expect them to take daily? So key word here is expect. And that word expect means that we should calculate the expected value. So we had our formula, and we're just going to put that formula into play. So there's our formula. same thing we wrote on the previous page, specific to this problem. And we're going to add another column to our chart to calculate this. So you can see my last column is m. I use the asterisk here for times the probability of m. So my first column is m times the probability, so 0 times 0.18 would equal 0. 1 times 0.41 would be 0.41. 2 times 0.13 would be 0.26. 3 times 0.8 is 0.24. You can use a calculator to help you with these, or you can do them in your head in this case. 4 times 0.7, 0.28. 5 times 0.8 is 0.4. And 6 times 0.5 would be 0.3. So what we've done is this part in the middle of our formula, we've taken m times the probability of m for each and every one. Last part of our formula is this portion where we're to add them up. So we'll put the sum down here as an extra box. And that's where I'm going to go to my calculator. So take on my calculator, 0.41. You can type the 0 if you feel like it, and type all the rest in. And when I get that answer, I have 1.89. Now, our rounding rule that we went over before is to keep one more digit than our actual numbers. So our actual numbers had to be whole numbers of the number of meds, and we'd keep one more digit than a whole number, so I would round this to 1.9. So I could say the expected number of meds, or I could say the mean number of meds is equal to 1.9. Now I realize it's not feasible to take 0.9 of a med, but that's okay. We understand an average is on average right about 2 meds is the average amount or the expected value. Next, we're going to take a look at standard deviation. So our question is just telling us find the standard deviation. We'll go back a little bit in our notes. We know that standard deviation is related to variance. And when we look in our textbook, there are different formulas given for finding standard deviation and finding variance. There's different options. We're going to work with the option that's easiest to calculate by hand, and that is this option right here. And these brackets did not turn out well. So these were supposed to be brackets right here. So sigma squared, this is variance. And the variance means that we sum up this amount in here, and then we subtract out the mean squared. And if we remember, the way that standard deviation is related to variance is that we take the square root of the variance to get standard deviation. So our formulas here are the same, except we have the square root. And since we took the square root and squared canceled, and so we have the Greek letter for standard deviation because it is a parameter. So this is a lot of work by hand, but we have a fairly small set to work with. What I'm going to do is I'm once again going to add another column to my chart, and in that column I'm going to calculate these things here in the bracket. So I'm going to take the x squared, which in our case is the m, because that's our variable, and multiply it times the probability of that variable m. So add some room in my chart. And I am going to take some time to just do some writing here so that you see how it all works. So in the formula, m squared, so that would be 0 squared, times the probability, 0.18. 0 times 0, that's 0 squared, is still 0. So this would equal 0. So the next one, I do 1 squared times 0.41. 1 squared is 1, so this is 0.41. Next one, I'm going to do 2 squared. So I can do that in my head and have 4, or do that on my calculator. And so I'm really taking 4 times 0.13, that probability, and on my calculator that came out 0.52. Next one, I do 3 squared. 3 squared is 9, so it's really 9 times the probability, 0.08. And again on my calculator, 0.72. Next I do 4 squared, so that's 16 times 0.07. And on my calculator, that is 1.12. 5 squared, or 25, times 0.08. And that comes out as exactly 2. And then finally 6 squared, or 36, times 0.05. And I get a value of 1.8 for that. So the next piece on my formula is this sigma. I've done this part. This is in my chart. And so my next part is to add them up. So again, like I had done before, I'll put this down here. What is the total from this column? And again, I went with my calculator, took 0 plus 0.41 plus 0.52, etc. down through, and I got 6.57 for that value. So I'm not done, but I'm getting closer. So now I have all this done. So I'm supposed to take this and subtract the mean squared. So I have 6.57 minus, and it's never good to round until the very end, so I'm going to use 1.89, that unrounded mean that we found before, squared. And so I do that on my calculator, and that gives me 2.9979. So this number right here, this is before the square root, so this is the variance. And so then I have to take the square root of that. So to get my standard deviation, I'll take the square root. And my calculator came up with 1.731. And again, that final answer, I will round one more digit than my data. So my data was a whole number. So I'll say the standard deviation for this is 1.7. So lots of work. Later you're going to learn how to use technology to do this for you, but for now, that's how you do it by hand for a very small set of data. So let's look at another question. In this question, we're asked for the range of usual values. Now, you may remember, if not, I'm going to remind you, for the range of usual values, we have a rule of thumb, and that rule of thumb tells us that the minimum would be equal to the mean minus 2 standard deviations, and the maximum usual value would be the mean plus 2 standard deviations. So I've calculated all these pieces and I can plug them in. So our mean was 1.9 and our standard deviation was 1.7, and that will give me my minimum value. And I do the math on my calculator, I came up with negative 1.5. And then do the maximum usual value, so mean 1.9 plus 2 times standard deviation of 1.7. And I put that on my calculator and I come up with 5.3. So usual values are from negative 1.5 up to 5.3. Now obviously no one can take negative meds, so our usual values really would go from 0 to 5.3. The only value in our data set that's beyond that would be the 6. And so that's how we answer the questions about the middle, the mean or expected value, the variance and standard deviation, and also the usual values when we're working with a discrete probability distribution.